This is our third AI incubator. Ooh, lentil soup lunch. I love that. That sounds delish. Um, yeah, thank you all for being here. Thank you, Benjamin, for coming back and facilitating for another session. Hi, Arjun. So good to see you. Happy Thursday.
Halo, halo.
Let me see here. Okay, yeah, so I'll just give a brief intro and then I will hand the floor over to Benjamin. But it looks like you guys don't need anything tool-wise today. Everything is just web-based, so you'll be able to follow along with Benjamin. And just a quick intro to Mona. You guys are all here in our Discord, so I'm sure you're familiar with this, but Mona is a metaverse world building platform built for creators by creators, and our mission is to empower people around the world to create, collect, and share high quality immersive experiences on the blockchain. Our AI incubator is our beginner friendly, there we go, think tank or workshop, introducing and using AI tools in an interactive way. As I said before, this is our third one. We started these up this year. And today we have Benjamin back coming to teach us some things for the second time. Some of you might remember the amazing presentation he gave on 404's AI generated world, Mona World, on our community call a few months ago. And at our last AI incubator, um, Benjamin, the theme was computer vision and image analysis. So this is kind of building off of that. Last time we were working with like building off of mid-journey skills and some fundamental basics for 3D generative design and 2D AI manipulation. And today we'll be taking it a step further and diving into 3D AI generation. So I hope that sounds good for all of you builders in here, because I'm just a bystander, just here for the knowledge and the vibes. So I will hand over the floor to Benjamin.
Thanks. Yeah, I'm excited to be back. I was trying to put some thoughts around what would be a good next step, because I think these workshops are really interesting for me to work on, and I'm trying to strike some balance of how if you're not super familiar with coding, we get to more and more advanced kind of generative design principles. And so the thinking was that last time we looked at 2D image manipulation in a somewhat meaningful way with the control net and stable diffusion running. And today, the focus will be on starting to apply textures to 3D geometry. And then if you'll have me back for a third one, we'll do 3D geometry generation. But each step is kind of important for a basis for how to think about building in 3D or generating with AI in 3D. So I'm trying to structure it in a way that makes a little bit of sense here. And last time we worked through Replicate, which was an online kind of repo essentially for different AI models. And today we're going to go one step closer to coding, which is we're going to work through Google Colab with actual code that our team has written to kind of help you along. But so you don't need to know any coding, but if you are interested, all of the code is there and available, so you can jump into it, and we'll kind of look at how you can easily manipulate it. So I think as a starting point, I can share my screen. I can also give you guys the links here. So let me go to the screen.
Right now, what everyone's being instructed to do is to create an account on huggingface.co.
Can you see my screen?
Yes, let's
Okay.
go.
All right, great. Sorry. Right, so what we are going to do today, do you even see my screen when I'm changing tabs here? Yeah, perfect. So we're going to be looking at a pretty recent, like 2 month ago paper on 3D texturing from text prompts, which is kind of a pretty cool thing that's been developing quite quickly. And so the idea here today is to experiment around with if you would have a base model that you've created in really whatever software or downloaded off the internet, you'd be able to kind of texture that model using text prompts and in kind of some pretty like interesting and weird creative ways. So that's the goal for today. If everyone is at this stage, I'll walk you through for people who don't know how to use Google Colab. It's essentially just an online platform that you can run different code. A lot of people will share their code publicly, like what we've done with this code that we've written. So probably the first time you opened it up, you saw a message that said something like, do you want to trust this workbook from Michal Busta, who's our Chief Technology Officer? And so yeah, that's kind of how this is working here. So it's pretty straightforward. You just hit the play button here. Now you get this notebook was authored by Michal, and you can go ahead and hit run anyway. And I thought, I know this is kind of meant to be like a beginner tutorial into AI, but what I like to do is at least sort of expose you guys to some different elements of coding in general, and especially like AI specific coding. So I'll try to walk you through a little bit what's happening in the process as we start to get to our own results, so that you kind of feel like you have a control over the process. So all that's happening right now is it's installing requirements, as it suggests here. And this just means it's installing things like Python, which is the scripting language we need. It's installing different libraries and sets of script that are dedicated machine learning repositories. Yeah, it's installing certain things to work directly with your GPU in order to do training. In this case, it's not actually your GPU, but Google's GPU that's being used. And yeah, this is a pretty straightforward process for almost any ML process that we go through, is to make sure you get all the right libraries and they all sync together. So I assume that probably we'll all be able to kind of move through this at about the same pace, and it's sequential here. So you can see that while this is thinking, it's still continuing to execute different lines of the code, and when it's done, you'll get a little green check mark here. You can also kind of look at the folder structure if you click this folder on the left side. And a little bit later, that will be important when we want to kind of look at some of the OBJ models that we're putting.
Sorry to interrupt a moment. That I joined it early, but I was not able to do a call. Thanks, Bnjm. But can you put some of the links, because I see that he's putting install requirements, but yeah, a little bit of guidance. Thank you.
So to start with, all we're going to need is just this one link to go to Google Colab. And that should take you to a page that looks pretty similar to this. You might not have any data here yet, but you'd have at least the starting code. And this is basically just a notebook of code that our team has written for the workshop. So once you go there, you just hit the play button. It'll run. It takes around, like, this is the estimate, so it ran around a minute or so. It actually around a minute and a half, 104 seconds. And then there's a little check mark, and you don't have to worry that it gives you an error here around the pips dependency. That doesn't affect this computation. So the way that Google Colab works generally, like, you can find some really interesting scripts online, because this is where people are kind of writing raw code, and you just follow it sequentially. So then the next one here is you just hit play after this one has the green check mark. This one only had to install one dependency, so it was really fast. It took like 1.7 seconds, at least on my computer here. Then I can go to the next one and just hit play. So yeah, even if you're not at the same spot that I am, this is the sequence to go through. You just kind of move down the list, and what it does is it installs these dependencies and these libraries. Right now, we're in the very first stage of this, where we need a bunch of other components of code in order to do something on the AI side of stuff, and you can ignore these these errors that you're getting. So I'm going to keep continuing on, but if somebody would like me to slow down or need something, please let me know, and I'm happy to do that. But in general, you can see the code executing in your window here. And this one of the install Pyralis and some of the other modules here is the last set of requirements that we need. And so now we get to another section of the code, which is the clone, the texture paper repo. And the texture paper repo is this, which I know I haven't sent you the link to, but I will be happy to send you the link to this in the chat. So this is what we will be executing today. So I'm going to go ahead and continue on. So if you have check marks all the way down, we can go to the next one, which is the git clone command. And now it's basically getting the code from this paper specifically, so what the authors had written and shared publicly. So we'll just kind of continue on until we get to the login to Hugging Face here. And now we're going to have to just take a moment to make sure that everyone has a Hugging Face account. So again, Hugging Face is really similar to what we looked at last time on Replicate. So it's kind of an online repo that also has data storage that allows you to interact with certain sets of code. So in your Hugging Face profile, once you've made a profile, you can come and click here on the upper right. You can click your profile. You can go to settings, and then you can go to access tokens. So I'll just say it again. It's your profile on the upper right. It's your settings, and then it's your access tokens. And then you probably don't have any here, but the one that was working for me is the right one. So you would just go to new token. You can name it whatever you would like. Change the role to right, and then generate that token. So I'll pause for a second to make sure that everyone is up to speed in case somebody started installing the repos a little bit later. You can also, if you're still at this stage where you're installing dependencies and requirements, it will install it in the background, so you don't have to wait on this page while things are installing. So once you have this long code, you can just click these two little boxes here, which is copy it to the clipboard. And I'll go ahead and start this next phase unless anybody really, unless you need me to wait, just let me know. But it's, again, pretty straightforward process. So you click the start button. Now it's looking for a token. So actually, you'll see that your cursor changes when it's over here. And if you click, a box will appear. So now the easy thing is just to Control V. You put your token in. You hit enter. It now asks you a second question, which is, do you want to use this as a Git credential? You don't in this case, so you just hit the letter N and hit enter again. And now it says your token is valid and your login was successful. So again, I'll just repeat it because this is a part where you had a couple extra steps. You click the run button here. I can do it again. You click the run button here. You click next to the token to show the box. You paste this this code in. Just hit enter. It's asked if you want to use it as a credential. It's not necessary, so just hit N for no and hit enter, and then you should see login successful here.
Okay, if you have done this before doing the login, because I was hitting play, install, it's okay.
Yeah, it's fine.
Yeah.
It's if you hit it, it's just going to start it over again. So like you don't have to go back to the beginning. You can just hit play. Like even here, I just did it a second time in a row, and it's fine.
Cool. I see that there's an other error that I am having, that is Google version installed. You have the version number 1. We ignore that or not?
Um, I haven't seen that error, so
Is
we'll see if it's going to be a problem. But do you get a check mark next to the Hugging Face here?
let me see. Yes, I have the check mark, so it allow me to continue installing things.
And does it say login successful, or this is where you have your problem? Is in
Uh,
here.
well, it's trying, it's running, still waiting.
I'll just do
Uh,
it one more time in front of you in case it helps, but it's probably fine. But so I just started again. So here, for example, I see it's asking for token. So the token it wants from me is the one that I named as Mona Demo, right? The
okay.
naming doesn't matter. I just press these buttons here to copy it. Then I paste it in. I hit enter. It asks this next question, which is if I want to add it as a credential, I just hit N for no, and I hit enter again, and then it tells me login successful. So it should be pretty quick, usually.
What means as JIT credential?
It's asking if you want this token from your Hugging Face account to be used as well as a credential for your GitHub account. And in
Okay.
this case, you don't, so
No,
you just hit N.
thanks.
So then we basically are ready to start actually running the paper. So the first thing we will run is the main script, the text-guided diffusion of a bust of Napoleon. So we'll hit run here, and we'll look at like what's happening a little bit more, because now some of the scripts are going to take a little bit longer to run because these are the actual machine learning scripts. So if you click this little folder structure over here, you can pop out the different options you have. And you should see something that says texture paper here. And that's because in this particular environment that we are working in now, or kind of like this set of code, we have cloned the repo, and that means we've brought in all of the data. So if we click the error, we can see, here are everything from the Python scripts to the underlying 3D forms that they brought. So by default, there is a Napoleon object here, which is a 3D scan of a bust of Napoleon. And we can also kind of go and see that, okay, there's configs, text-guided Napoleon. So if we find configs and we open it up, we see there's another folder called text-guided. And then there is something called Napoleon YAML file. And if we click that, or sorry, double click that, we can see what that is over here on the right. So you could think about this as just a simple kind of guidance for the AI in this case. So here, the experiment name is called Napoleon, and there's really only two pieces of information that we need. One is the text input for the shading for the material which we're generating. And by default, the text input is a photo of Napoleon Bonaparte. And the shape path is the folder called shapes and the OBJ file called Napoleon. And then the append direction is simply about the order of camera angles that it will take in order to create a material. So we will look after this one is finished running. We will look at how to kind of change our own models here, but this is pretty much the only key factors that we need to deal with. Is we have a shape path, so we have an underlying OBJ file. So you may have this from your own modeling or from something you download off the internet. And the only thing really important here is that the file type be OBJ and that the meshing of it be triangulated meshes, which is by default. So in most cases that should be fine. And then the other piece of it is just what you would like to create as a material. So here we can see that it's going through and downloading all of the various scripts, and this will take a few minutes. So while this is going, it's possible to leave the page, and I'm just going to go look a little bit at the paper to show you what we are doing now. So here, for example, is our model of Napoleon Bonaparte, and this is probably very similar to the texture we're going to get back because it's their default example, and so we are using a similar text prompt to create that. I just look here and it's still running. So before I kind of show more of the paper and some of the places this can go, is this pretty understandable to everyone what we're doing so far? We've installed a bunch of libraries that are necessary to run the machine learning code, and now we are at the point where we are running the code with really just two inputs, an OBJ file, which is our mesh file, and a text prompt, which will basically create our materiality. So if that's not clear, we can discuss it. But I think part of the idea here is to to give you a little bit of a look under the hood for the machine learning models, because there's a lot of interesting things out there that you can play around with, but it's helpful to have a little bit of a starting point like this Google Colab file, but also being able to look through and understand where you can change different parameters. So here it's fitting mesh, it's doing coloring, and so now it's 10% done with that stage and should start getting pretty close here, and then we'll be able to see the next phase.
Sorry to interrupt again, but I am very delayed. It's I'm still in the hanging phase thing, and I created a new token, and it's asking me for write or read. Should I choose write or read?
Probably it doesn't matter, but you should choose write because I'm sure it works with write.
Okay, cool.
So now it's continuing on. While it keeps going, I'll just show from the paper a couple of other examples that they've effectively done. And from our tests, what I think I sent this link just so that people can follow along. What generally works best is when you're able to use a text prompt that is fairly accurate to the geometry that you are creating. I mean, it's quite fun actually if you change it up and you take, for example, this turtle or a frog or something and label it as a raccoon, because you can really see in the glitches of the texture how it's working. But what you start to get is stuff that looks kind of like 3D versions of like Midjourney version 1. So we know this kind of technology will continue to improve and do interesting things, but it's kind of a nice way if you really want to have like a 3D textured AI object. Quite nice. And you can see here, like what they're trying to show in this set of examples is it's the same underlying mesh, but just by changing your text prompt, you're able to create different types of fish, in this case, a piranha, a goldfish, and a pufferfish. So let's see if this is still going. Okay, it's 60% done, so still has a little ways to go, but this is the longest phase of the training, because after that it's basically done. And what it's doing now is it's basically taking different views and it's painting on the texture from a two-dimensional image. So in the paper, it probably explains in a more meaningful way how it's working here. So what we are doing right now is this iteration 1 through T, where it's taking the camera from different angles and then generating a 2D image of what it thinks that object should look like, and then projecting that texture onto, in this case, the orangutan. All right, 80% there. Great. And it's very nice that in this case they license all of the tech out to be used so that people can use it for creative things. So if you want to use it actually in your world building experiments, you can. And I think it's very nice. You can even see how you can try to add different elements of texture. So this one they called a plush toy versus a plastic toy, and you get a certain difference in the way the textures are applied.
This is amazing. And we have one question in the audience
Oh, yeah.
asking, does this run better or worse locally versus a cloud instance like this?
Yeah, I think, it depends, of course, on what your hardware is. In general, it probably runs a little bit better locally if you have decent GPU. The thing that's very frustrating when you do this locally, it depends a little bit just on your background, but it's very easy to get inconsistent like installation requirements. So the best way to do it is set up a environment in Anaconda, and that should probably solve it pretty well. We run it locally sometimes when we want to play around, and you don't have to worry about your internet connection and all of this. Yeah, that in general. I mean, it depends on how much you wanna use it, really. So if for example you were going to build out a whole Mona world and you wanted to create a texture for every single 3D object in that world using this paper, this texture paper, it might be worth the extra problems that will come from the installation requirements. I mean, it can work out of the box sometimes. I just know from experience that there can be some frustration when you have an inconsistent GPU requirements like PyTorch installed on your machine that isn't corresponding to some of the other requirements it needs, and that can be a little bit frustrating in the setup. But once you have it, then you have it, and you can run it as much or as little as you want.
What's the recommended GPU then that you recommend for this kind of work?
Actually, I am not sure, and they probably will have some recommendations in the paper that I can look for. We have, I must say, quite strong GPUs because we are a 3D AI company, and so we have things like Titan GPUs here that are kind of meant for heavy computation and machine learning training. But that shouldn't be a limitation in this particular paper. So I can have a look through maybe after the call and follow up if there's any particular GPU. But as a general rule, it's kind of nice if you're doing a lot of machine learning or you're interested in doing a lot of machine learning to have like a standalone desktop computer, and then one of the main requirements becomes the memory of the GPU. So Titan is quite large with 24 gigabytes, but even I think some of the new NVIDIA 3090s and 3080s and stuff like that have it. So yeah, I'll just because it takes some time to always render out, I will move to the next step here, which is now just simply displaying our model. If your model finished, and you see it took quite a while, so 10 minutes and 40 seconds. And this beautiful Napoleon Bonaparte is what we created here. You also have here on the side where you can download him under experiments here. So you ran the experiment, you called the experiment name Napoleon, and now you have things like the checkpoint of your AI, but you also have the mesh here. So you could download the mesh obj file and the mesh material file. And with this, you could now place this into a scene, for example, in Mona. I'm going to start another one, just that will start running. So this is where the out of the box demo ends, and where now we've written a little bit of new code to kind of help you play around with it. So I'll just talk you through a little bit of the code here. So this is simply downloading a new OBJ model, which we have made or which we have found online. So if you would just control and click this link, you don't have to do this, but you could just look. What it's doing is it's downloading a model called woodenfrog.obj. It's just a model of a frog. And this is simply saying we name this model wooden frog. So if I hit this, it now goes very fast. And we can see we can see that we've now downloaded it. So we have 100% downloaded of this 3 megabyte file. Continuing here, we are now getting ready to run the Napoleon script again, but in this case, we are changing the parameters. So this is kind of the script that you would need when you want to start experimenting. So what's pre-written in here is the path goes to woodfrog.obj, the frog that we just downloaded, and the guidance text changes from a photo of Napoleon to angry poisonous frog. I already have what that looks like, so I'll maybe just change this to raccoon so we can also look at like when it doesn't apply texture as well as it should. And so I'll go ahead and hit start on that one. And this is now probably going to take around another 5 to 10 minutes to run. So we can look at a couple of other things in the meantime while this goes. But you can see here, this is what I think the old generation was a happy poisonous frog or something like this, and it made this one. It's already kind of loaded in because we had previously run the script. I'll just, if there's any questions, I can take them now while this is calculating. Yeah.
I have a question. Is this the tool that 404 was working on, or is this something different?
This is slightly different. So what we are trying to build out with 404, I mean, we use similar technologies or at least similar principles. So in this case, what is happening is it's looking at the 3D model from different perspectives. It's taking synthetic depth estimates of that, and it's trying to project texture from different viewpoints onto the model. 404 used a little bit of a different tech stack, one that we had that we have developed ourselves. And the goal very much actually is sort of by the crescendo of these workshops to probably just give everybody access to 404's kind of generative AI basis so you can play around with it, and it should also be kind of pretty user friendly. But we still are kind of in the development phase of how to roll that out with a nice user interface, and that you don't need to know any coding language, and also working with Mona to see what the training data should be, because like all AI, it's the outputs are kind of very much dependent on what input data you give it.
That's amazing. Oh,
So
sorry. I was gonna say
no,
we would.
I just saw the question come in about how quickly we think no code tooling for this will come. We're pretty optimistic. We already offer no code generative AI tools, largely just for kind of industry clients. So a typical workflow for us is that a game developer would give us reference images, for example, mood boards of their upcoming game, and we would have a conversation around what they are looking for. So for example, maybe they want their game to be hyper realistic, or they want to have integration into Unity, and so that their users can write some text and generate models. This is typically what we do with my company which is called Atlas, and it's also something that we're exploring with Mona to by the end of the year have a similar setup in Mona where you can just write a small phrase and you can get back a textured, cleanly modeled 3D piece of geometry. And this is in progress, but probably still a couple months away with all the training and the fine tuning that we have to do to get the exact geometry results that we want.
That would be gorgeous and amazing. I have well, I only have a note. If you need testers, count on me.
Yeah, one of my thinking is that maybe these AI workshops are a good chance to test out earlier versions of it because the user interface doesn't need to be as polished. Even here we're just running raw code. We're just running it simply through a Google Colab setup here. So I think there's probably a good chance that we will need some early testers and would love to have you try it out.
Thank you.
Welcome back anytime. We love to have you do this.
I mean, what we always put an emphasis on, I mean, I can just talk through it because we're at 70% still of this next training one. What we always put an emphasis on is that we want the geometry to be as clean as possible. So where, for example, I think the reason we don't use this this technology that we are playing with today, for example, is because when you look at these kinds of results, and we will see it more in the one that's being generated now, which is a raccoon based on a frog model. The geometry is kind of hard to edit afterwards. It's a lot of very dense polygons, and that's kind of difficult to further manipulate in a meaningful way. But what we've built is a mesh generation system that has very clean polygons with edge loops and clean faces and topology. So it should be that even if you don't know how to expertly manually model anything, I think all the tools in Mona will be more than enough to kind of make it completely your own. So you can always play with it after the AI is finished.
That's so super useful for 3D content creators and artists in general. So especially if you want to enhance the metaverse, so as a 3D tool and a 3D environment. Kudos.
Yeah, thanks. We're really excited about it, and we know that some of the big, we even work with companies like Square Enix, which is like a very large game developer, or Yuga Labs, for example, and we know these guys really like it. But I think we're more excited when it has a use case in sort of user generated content, or really helping people that maybe are not as familiar with 3D modeling software. So here we will see maybe, I think, an example for why we don't use this approach as much, although it's quite fun. So here my training is finished. So what we did is we uploaded a OBJ file of a frog, but used the text input of a raccoon. And you can see here that actually this raccoon is not so bad. But when you start to rotate him, he starts to look pretty weird. And you can also see that he got a little bit messed up back here. And this is probably then a very nice kind of understanding, maybe this shot here, of exactly how this network is working. And you can really understand it now, because it's trying to create this object from multiple points of view. And it's doing sort of multiple single projection images. So here, when we are at this looks really good, I would say. You would think that, oh, this raccoon definitely is going to look really good. But then when he starts to turn around, he gets a lot of kind of very strange things, even when he's just slightly rotated, like he is somewhere over here. But it's a fun tool to play with, in my opinion. So, and if you're not super worried about how one-to-one accurate your approach is, then it's fun tool to play with. And you now basically have all the code here, and we'll just leave this available online. So you have all the code here to upload your own 3D models. All you would have to do is change this link So you just go into this code here and, delete out whatever you want and put in your new link. You can call it whatever you would like, .obj. So this would be where your obj file is. And then in your next step, you'll see that here you just need to put in your text phrase and your wooden frog, your obj file. And you don't need to worry if you mess something up and you change the code and you can't undo it, because if you click the link, it'll ask you when you leave if you want to save your changes. But you can save your changes to your own Google Colab account, but we've set it so that you can't overwrite this file, so you can always go back to this file and start again if you mess it up. So you should feel like super free to play around and not worry that you're gonna ruin the code at all. Yeah.
That's important, is what I was going to ask you now, because if, for example, I want to put in there in the certificate, my own folder, then it's not going to be a problem, right?
Shouldn't be a problem. You can see that basically the way we've set it up right now, in order to be the most flexible, it's looking for a Google Drive folder. So what you would do is you would upload your OBJ file to Google Drive somewhere, and then right click it and say, get link, and then just paste your link in here, and it should work.
Okay. That's pretty amazing.
And I think we have just 5 minutes left. So I have one very short thing to share for 5 minutes if people have time, but otherwise happy to do it on the next one. But if people have time, we thought it would be kind of a fun thing to show and to kind of give access to. So I'll just put it here. This is a little tool that we developed. It's using some of our in-house tech to play around with. So you'll need a password and a login, and you can use Mona demo as your login, and you can use Atlas1 as your password. And all this is basically using one of the largest 3D libraries in the world with permissive license that is without metadata, but we use computer vision to find models. So for example, if you would like to do a frog, kind of a funny one, I know it from testing it earlier today. The first time you search, it will take a little bit of time because all of the neural networks that are behind this search engine now will be booting up. But what it's trying to do is use your text to create an image that you don't see of a frog, and then it's looking for all of the models that it can find that would be similar and look like a frog. And it's doing it looking for models that are available for you to use within scenes, like a permissive license, for example. You can read more about the license down here, but here now you have all of these little frogs that you could use in a scene, or that you could use, for example, to retexture, which we thought was kind of a fun little play here. And the reason that I wanted to search frog, which is kind of a nice one, is because you also see some of the limitations of this type of searching tool, because the AI thinks this looks like a frog. It's not completely wrong, because it kind of does look like a frog. But in fact, of course, it's not a frog. It's a little scene. And so if you wanted to use, for example, this as the basis for your texturing, you could do the full screen view of it. You could look it around, and then you can download it. And now you have what downloads as a GLB file, because that's the nature of the database and the repository that we are using. But you can, in any 3D software, convert that to an OBJ, and as long as you use triangulated mesh, you will be able to use that in this retexturing tool. So it's a good chance to get some starting models, to have a little bit of fun, and then maybe even use AI to make them your own.
Wait, this is free to use?
Pardon?
This is free to use?
For Mona, it is. It's just our internal something that we set up a little bit internal to play around with. So we will build this out into a much nicer tool, actually. But what we will build maybe for the next one is a little bit of actually a scene generator. So you would actually be able to write something like, I'm looking for a cabin in the forest surrounded by frogs. And you would get actually a whole scene that you could then take into Mona and start to play with. But for now, it's just a little bit single asset generator, and something just for fun to play around with.
Already coming so much ideas. I'm already generating some of them that I can actually put in one of my worlds. So
Yeah, they're fun little experiments, and part of the thinking of including it here is that now you have the Google Colab notebook that we made in order to retexture them, and I think some of these models would be ideal. Like this cute ghost is a pretty good one for retexturing, because with a little imagination you could imagine that maybe that's a penguin, for example, and if you will put that model into the Google Colab notebook as a OBJ, and you will use your text prompt as penguin, maybe you can turn him into a cute penguin, or you could put cute penguin, I guess, as the prompt. So that's what we've got for today. And yeah, thanks again for the opportunity to show you a little bit of machine learning, and hopefully it's helpful and interesting and can help in your creative process.
Another amazing workshop. Thank you, Benjamin. And I love how timely you are. Ended right at 1. We had 2 minutes to spare. Thank you so much. I hope that everybody got something from this today, and I definitely look forward to our next session with you. All right, cool. So that's it for today. Thank you all. If you guys would like to go back and revisit everything that Benjamin shared today, this session was recorded and it will be uploaded to our YouTube channel for your reference. And yeah, be on the lookout for the next one. Also, we do have a pop-up event happening in about 30 minutes. I'll be streaming Justin and Matt live from Consensus and here into our Discord. Justin is speaking on the Protocol, I think it's the Protocol podcast with Josie and a couple other amazing folks. So if you're interested in getting an exclusive sneak peek into that discussion, I'll be streaming it here in about 30 minutes. So hope to see you guys there. And if not, hope to see you guys tomorrow at our community call here on the main stage at 2 p.m. Thank you again, Benjamin. If you guys want to stay connected with Benjamin, you can follow him on Twitter. I believe your handle is at 6329, right?
Yeah, that sounds right.
Okay, cool. Yep, you can follow Benjamin on Twitter at 6329. And hope to see you guys soon.
Thank
Thanks,
you all.
everyone. Thanks, Benjamin.